to learn some math. Learn some math.
You just know it's a great day when you get to learn some math, so let's go ahead and make it a great day and talk about volume of pyramids and cones. Your learning target is I can find the volume of both pyramids and cones. So the volume of a pyramid, it's calculated by multiplying the area of the base, which we call B, times the perpendicular height of the pyramid. Okay, so you can see that it depends on what type of shape. If it's a regular pyramid, then we're just taking it from the very center up to the top. But if it's an oblique pyramid, you have to find that height from the plane all the way up to the top. So essentially it's the vertical distance, the perpendicular distance between the plane, the base, all the way to the vertex, the very top of that pyramid. And we can write out the formula to be where it's V, meaning volume, is equal to 1/3 times the base, the area of the base, times the height of the prism. So 1/3 BH, okay? And that B is changing, okay? It's changing depending on what the shape of the base actually is. All right, let's get going on an example. All right, example 1 wants us to find the volume of the square pyramid, and we have to round our answers to the nearest hundredth if we need to. So here's what we're given. We're given this really cool pyramid, and the dimensions that we're given is that this is square, 20 meters on both sides, and we're given that this pyramid has a slant height of 14.14 meters. So let's go ahead and write out our formula. Just remind ourselves of that real quickly again, even though I know we just wrote it up there. So we have to find the volume is equal to 1/3 times the area of the base. Now the area of the base is pretty easy to figure out. It's just going to be our 20 times 20. So we're going to multiply 20 times 20. And then we're going to multiply it by the height, okay? We're going to multiply it by the height. Now the height is interesting because we actually don't know the height. We're not using the slant height. Remember I said the height is the perpendicular distance between the base and the vertex. Okay, this is the slant height. We have to find what the height is. And actually, if we were to pull this shape out, we could pull this shape out into a two-dimensional figure and make it somewhat of a triangle in order to figure out what that height is. And we can see this is a right triangle, so we can use Pythagorean theorem. Pythagorean theorem says that h squared, our height squared, plus the base, so a squared plus b squared. This base, we actually know what it is. We know that because this is a regular square pyramid, that this distance is 10 meters, so 10 squared, is going to equal our slant height of 14.14 squared. All right, so all we have to do then is we just have to subtract 10 squared from both sides. And we get h squared is equal to, at this point that's when I use a calculator, right? Because I don't know what 14.14 squared is. And we're going to subtract 10 squared from it, which is 100. And we get 99.9. 99.9. We're rounding to the nearest hundredth though, so we'll go 99.94. Okay, 99.94. And remember that at this point we still have to take the square root of both sides to end up getting that h is equal to, well, wait up. Let's use this whole number still. So we're going to do the square root of the answer. Remember, answer is second, and then that button that's near the enter button. And we get 9.996, which all of that's going to round up to 10. So the height of this pyramid is about, we can make this a little about symbol now, about 10. All right, now we can plug that into our formula. Remember, that's what we were looking for, was the height here. And let's keep on solving. We know 20 times 20 times 10. Well, if we forget about those zeros for a second, 2 times 2 times 1 is just 4. So we're going to have 1/3 times 4 and 3 zeros, so we're going to put those 3 zeros back in. It's going to be 1/3 of 4,000, which just so happens to give us a volume of 1,333 point, remember rounding to the nearest hundredth, 0.33. And we got a label. Remember, this is meters, and we're talking about volume, so it's cubed. volume cubed. Alright, example 2, we're trying to find the volume of the pentagonal pyramid, and we need to round our answers to the nearest hundredth once again, if it's necessary. So remember, I always like to start out with the volume formula, 1/3 times the area of the base times the height. Don't be afraid to start out with that formula. Oftentimes the way to be a great mathematician is to stay organized, right? So first we're going to need to find out what that area of the base is. And we have a pentagon. And so the area of a regular pentagon, which this is given by the formula 1/2 times AP, right? Where A is the apothem, P is the perimeter. So our apothem, this is given to us here. We have some information given here. The apothem is just 3 feet, and our perimeter is 5 times 5 sides, which is 25. Okay, 25 times 3 is 75, and 75 divided by 2 is just going to be 37.5 feet squared. That's the area of the base, just that two-dimensional pentagonal figure. And so we're going to plug that in for the base now, 37.5. And the height of this whole pyramid is ending up to be just 73. And so now all we have to do is just multiply all this stuff out. 73 times 37.5, all divided by 3, so multiplied by 1/3 gives us 912.5 feet squared. 912.5, talking in feet. Sorry, not squared, but cubed, because we're doing volume. And that is the area inside that pentagonal pyramid. Now I know you can't get enough of this volume stuff, so let's take a look at the volume of a cone. The volume of a cone is calculated by multiplying 1/3 times the area of the base times the perpendicular height of the cone. Okay, and so that can be written out as 1/3 times the area of the base times the height of the cone. 1/3 base times height, which you see is the exact same formula for the volume of a pyramid. We're using the exact same formula. However, we can write this one a little bit more specifically because we know that the base of a cone is always a circle. So instead of using B for base, we can write this as multiplied by pi r squared, since pi r squared is the actual formula for the area of a circle. And then finally multiply that by the height of the cone. Remember, this is the perpendicular height of the cone, okay? It's not just the slant height or anything like that, it's the perpendicular height of the cone. So let's do this example real quick. I'm going to use this second formula. I think that second formula is a little bit better for us. As long as you just remember that pyramids and cones are given by 1/3 BH, you shouldn't have a problem remembering that pi r squared is the area of a circle. And so let's go ahead and just write this out here, and then we're going to put in those pieces of information that we know. Now we know it's a right cone, and it has a diameter of 6 meters and a height of 12 meters, and we want to know what its volume is. And so all we have to do is just plug in the pieces of information that we know. We already know r because we know the diameter is 6 meters. Radius is half the diameter, which means our radius has to be 3 squared now. And the height is 12 meters. So we're going to multiply it by 12. Okay, so 3 squared is 9, and we see 9 times 1/3 is just 3. Okay, so we could write this instead as 3 times 12 pi, and 3 times 12 is just 36 pi. Now we can keep our answer in terms of pi, like 36 pi meters cubed for our volume, or we could write it more specifically and round it to some decimal point, and what we would end up getting is 113.1 meters cubed. This is an exact answer. This is an approximate answer, okay? But either one of them, as long as you've labeled, is a good way to do it. Alright, now we're on to the fun problem here. This is example 4, and what it says is a cone whose diameter is the same length of the edge. Okay, and I want you to understand that this is very important. The diameter is the same length as the edge. Okay, so this picture doesn't do this justice. That circle is stretching all the way from end to end. Okay, it's stretching from end to end. But its diameter is the same length of the edge, so we know the diameter then is 16 yards. Has been removed from the inside of a square pyramid. Find the volume of the resulting solid. So essentially what we've done is we have this big pyramid and we took out a cone from inside of it. And we want to know what is that volume inside of it. So really all we have to do is find the volume of the pyramid, find the volume of the cone, and then subtract those, and that will give us the volume of the resulting figure, the resulting solid. So let's go ahead and we need to find the volume of a pyramid, and we need to find the volume of the cone. So we're going to do that separately 2 different times here. And remember, the volume formula for a pyramid is 1/3 times the area of the base times the height. And so this is going to be pretty easy now, right? All we have to do is plug in those numbers. We've got 1/3 times our base, the area of the base. For a square, it's just base times height, so 16 times 16. And then multiplied by the height. The height goes up 30 yards, it says. Okay? Let's go ahead and just keep on solving here. 16 times 6, well, 30 times 1/3. We can kind of reorder this. That's a lot easier. 30 times 1/3 is just going to be 10, and then multiply by 16s on both sides. If I multiply 16 together, we're going to end up getting 256. That's 16 squared. And finally, if we multiply that by 10, we get 2,560. Remember, we're talking about volume, so this is yards cubed. That is the volume of this pyramid. Now for a cone, we can use the same formula, but remember, I like to use pi r squared instead, since we're talking about this area of a circle, instead of just using b for the area of the base. We're going to have to do pi r squared anyway. So let's go ahead and solve this one. We're going to do 1/3 times pi times the radius, and if the radius, remember the diameter stretches the same distance here, even though the picture doesn't show it accurately, it shows goes the whole distance, and the radius is then going to be 8 squared, and times the height again, which is 30. So we're just going to multiply this one out again as well. We've got 30 times 1/3 is just 10, times 8 squared is 64 times pi, which we end up getting our volume to be 640 pi. And that is the most exact answer that we can get in terms of volume for the cone. Now, in order to find the volume of the resulting figure, remember the last step here is to just subtract those numbers. Subtract 2560 minus the volume of 640 pi. And if we were to make an approximate of this, 640 times pi is approximately 2,110.6 yards cubed. Okay, so let's use this number, and we're just going to subtract these now. 2,560 minus 2,010.6. All we have to do is subtract now. We've got to borrow a little bit. And so we've got 10 minus 6 is 4. 9 minus 0 is 9. 5 minus 1 is 4. 5 minus 0 is 5. 2 minus 2 is absolutely nothing. And we're left with 549.4 yards cubed. That is the volume of this beautiful, beautiful figure in this beautiful problem. Now, after all of this, you can say you can find the volume of both pyramids and cones.
Stay in school, math is fun.